We have determined the exponential velocity of particle in vertical circular motion at different points. At uppermost position VB is root 5 Rg, at lowermost position VA is equal to root Rg, and at midpoint here D is equal to root 3 Rg. The tension at the upper position is TA is equal to 0. The tension difference between the point B and A is equal to 6 mg, and tension at point D is TD minus TA is equal to 3 mg. Now let us today discuss mass tied to a rod, to a uniform rod. Let us suppose a pendulum is tied to a uniform rod and massless uniform rod wheeled in a vertical circle. Wheeled in a vertical circle. What is the basic difference mass tied to a rod and vertical circular motion? वर्टिकल सर्क्युलर मोशन आणि मास टाइड टू अ रॉड या दोन्हीतला फरक काय आहे? In vertical circular motion, body always requires minimum tension or it requires tension in the string at every point. प्रत्येक पॉइंट वरती आपल्याला स्ट्रिंग मध्ये टेन्शन असणे आवश्यक गरजेचं आहे. टी But in what a condition है vertical circular motion साठी. The condition for vertical circular motion is there must be always tension in the string at every point. It may be maximum at some point, it may be minimum at some point, but there should be tension in the string. But in mass tied to a rod, as rod is rigid, this condition is required. Minimum tension condition is not required because rod is uniform and it is rigid. By applying the same phenomena or by applying this law of conservation of energy, we can determine the velocity at point A, velocity at point B, velocity at point D or C or D. Velocity at the uppermost position VB or lowermost position VB. By the same way, it is left to the students. It's homework. VB is given by 2 root Rg. And at midpoint, at point D, VC or VD is equal to under root 2 Rg. By same method as we discussed the vertical circular motion. And the tension difference TB minus TA, which is equal to again 6 mg. So by this way, a short article that is mass tied to string view concludes. आपण इथं संपतो. Let us discuss next article. Moment of inertia as a analogous moment of inertia as an analogous quantity for mass, as an analogous to quantity for mass, analogous quantity for mass. As I have already stated, Moment of inertia as an analogous quantity for mass. What do you mean by analogous? मराठीमध्ये एनालॉगस म्हणजे काय? एनालॉगसचा अर्थ काय होतो? समान, सारखा, समान किंवा सारखा. म्हणजे ह्या आर्टिकलचं नाव काय बघा, मोमेंट ऑफ इनर्शिया एक फिजिकल क्वांटिटी आहे. फिजिकल क्वांटिटी, मोमेंट ऑफ इनर्शिया ॲज एनालॉगस, सारखा आहे. क्वांटिटी कोणत्या क्वांटिटीशी? मासची. वन्स अगेन आय विल रिपीट किंवा मराठीत पहा. आपल्याला काय पाहायचं? मोमेंट ऑफ इनर्शिया हे सारखं आहे कशासोबत? मास सोबत. आता प्रश्न काय आहे? नाउ द क्वेश्चन इज that means we have to prove that moment of inertia is analogous to mass. Moment of inertia is a physical quantity which arises in rotational motion, and rotational mass arises in what? Translation motion. We have to prove that mass and moment of inertia are same quantity. Both are same quantity. So in the 11th standard we have studied that S or linear motion. In linear motion, S is said to be displacement. V, linear velocity. SV, acceleration. A, acceleration. In rotational motion, displacement is represented by angular displacement theta. Linear displacement is analogous quantity to angular displacement. Linear velocity is analogous to the angular displacement as angular velocity omega. Linear acceleration A is analogous quantity to alpha, that is angular acceleration. Let us see once again. Linear displacement is analogous to angular displacement. Linear velocity V is analogous to angular velocity. Linear acceleration A is analogous to angular acceleration. Now let us consider other equations. In linear motion, force is equal to mass into acceleration. Okay. Momentum P is equal to mass into velocity, and kinetic energy equal to half of mv square. Now let us go towards rotational motion. In rotational motion, in order to produce the rotational motion, we require torque or moment of force. Torque is equal to that quantity we don't know. Instead of linear acceleration alpha, this quantity we don't know. आपल्याला माहिती नाही. Angular momentum L is equal to, we don't know the quantity. Instead of V, angular velocity omega. And kinetic energy in rotational motion is equal to half of the quantity omega square. As alpha omega are analogous quantities, we have replaced as it is A to alpha, V to omega, and V to omega square, V square to omega square. What about mass? The mass term is involved in all the equations. In order the rotational analogy, we need to replace mass in in rotational motion. इथं मास जो आहे तो इथं मास राहू शकत नाही रोटेशनल मोशन मध्ये. पण ते काय आहे? What is that quantity? And that quantity we call it as a moment of inertia. ते कसं आहे ते पाहण्यासाठी let us suppose we have a door दार आहे, इथे hingesला अटॅच केलेला आहे. If you want to open the door, let us suppose apply a force at the end of the door. Effort needs is very small. या दाराच्या शेवटच्या टोकाला फोर्स आपण अप्लाय केलं, दार इजी पद्धतीने खुलतो. एफर्ट फार कमी लागते. तोच फोर्स जर मी इथं लावलं इंजिसच्या ठिकाणी किंवा ॲक्सिस ऑफ रोटेशनच्या ठिकाणी, म्हणजे आपल्याला काय होईल, फोर्स किंवा एफर्ट जास्त लागते. ह्याचा अर्थच काय? ह्या दाराचा जो मास आहे, the mass of door even though remains constant. Even the mass of door remains constant. To open the door, effort required depends upon what? It depends upon not only its mass of the body, but it depends upon the force, the point at which the force is applied. The point at which force is applied. If the force is applied at the end point, effort is small. If the force is applied at the nearer to the axis of rotation, effort required is larger. That means the quantity mass of door depends upon two: mass of body, mass of door, and then distribution of mass about the axis of rotation. How it is? Let us see. So in order to study in detail, let us determine the expression for kinetic energy of a rotating body or kinetic energy of a rolling body. Kinetic energy of a rolling body. Kinetic energy of a rotating body. Kinetic energy of a rotating body. So in order to determine the expression for kinetic energy of rotating body, rotating bodyचा kinetic energy कशासाठी काढलालो? मुख्य मुद्दा काय आपल्याला मोमेंट ऑफ इनर्शिया आणि मास ह्या दोन्ही एनालॉगस आहेत, आपल्याला सिद्ध करायचे, समान आहेत म्हणून सिद्ध करायचे. मग मोमेंट ऑफ इनर्शिया म्हणजे काय ते नंतर पाहू. So in order to determine the expression for kinetic energy of rotating body, let us suppose a rigid body is rotating about an axis perpendicular to the plane of the body. Let us suppose we have a rigid body. Rigid body is in this plane. The axis of rotation is perpendicular to the plane body. As the rigid body consists of a large number of particles of different masses, say m1, m2, m3, dash, ml. A rigid body consists of large number of particles, say particle 1 of mass say m1, another particle of mass m2, another particle of mass m3, say nth particle of mass mn. Let the perpendicular distance between the axis of rotation and the position of particle, say r1, r2, r3, rn. Let r1, r2, r3 dash 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 rn be the perpendicular distance between the axis of rotation and position of particle. So let us complete the rigid body. It is rotating, say, in this direction, omega. Diagram and description is over. Let us let us repeat once again. Let us consider a rigid body rotating with constant angular velocity omega about an axis perpendicular to the plane of the body. Let the rigid body consist of n particles of masses m1, m2, m3, dash mn, situated at distance r1, r2, r3, dash rn. That is perpendicular distance between axis of rotation and position of particle. First part is our diagram discussion संपला. आता काय फिजिक्स पार्ट, इम्पॉर्टंट पार्ट. एकदा फिजिक्स पार्ट आलं की डेरिवेशन आपोआप येते. त्याच्यात फिजिक्स काय आहे? प्रत्येक एव्हरी पार्टिकल रोटेट विथ सेम अँगुलर वेलोसिटी. But the distance between the position of particle and axis of rotation is different. Hence, their linear velocities will be different. As we know that V is equal to R omega. As the R is changing, their linear velocities is changing. Their linear velocities are changing. Or we can state that every particle rotates with same angular velocity, but their linear velocities are different. This is what the physics part. So V1, V2, V3, dash Vn be their linear velocity. एकदा आपल्याला फिजिक्स पार्ट समजलं, आपण डेरिवेशन जाऊ शकतो. डेरिवेशन में मुख्य मुद्दा काय? कायनेटिक एनर्जी ऑफ रोटेटिंग बॉडी. आता लिनियर वेलोसिटी माहिती आहे, लिनियर एनर्जी काढा, लिनियर कायनेटिक एनर्जी काढा. सो kinetic energy of a particle mass m1, or we can say before that v1 is equal to r1 omega, as omega remains constant, r is changing. v2 is equal to r2 omega, dash vn is equal to rn omega. Kinetic energy of first particle E1 is equal to half of m1 v1 square, half of m1 v1 square, or which is equal to half of m1 v1 is equal to r1 omega, or r1 square omega square, as omega remains constant, not omega 1. Similarly, you can determine E2 is equal to half of m2 r2 square omega square, dash En is equal to half of mn rn square omega square. Our total kinetic energy equal to E1 plus E2 plus dash plus En. En, or which is equal to half of m1 r1 square omega square plus half of m2 r2 square omega square plus dash 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 plus half of mn rn square omega square as half and omega square are common in every term, in each term. I take it out. Total kinetic energy or kinetic energy equal to half in bracket m1 r1 square plus m2 r2 square plus dash 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 plus mn rn square omega square. The quantity in bracket can be expressed in the form of summation or m1 r1 square plus m2 r2 square plus dash dash plus mn rn square equal to summation I runs to 1 to n mi ri square, or which is equal to, we say that is I. त्याला आपण I म्हणू समजा. Or kinetic energy of a rotating body is equal to half of I omega square. Kinetic energy of a body in translation motion is given by half of m v square. So in translation motion, kinetic energy mass m. If you compare these two equations, as v is analogous to omega, that is angular velocity, then the mass m is analogous to I, that is called moment of inertia. So I is called rotational inertia. It is called rotational inertia. Or it is called moment of inertia. मासला आपण समान क्वांटिटी शोधत होतो. ट्रान्सलेशन मोशन मध्ये मास जी क्वांटिटी आहे, रोटेशनल मोशन मध्ये त्याच्या समान क्वांटिटी, सारखं क्वांटिटी आपण शोधत होतो. कायनेटिक एनर्जीवरून आपल्याला लक्षात आलं की समान क्वांटिटी आय आल्या, त्याला आपण म्हणतो रोटेशनल इनर्शिया और मोमेंट ऑफ इनर्शिया. रोटेशनल इनर्शिया और मोमेंट ऑफ इनर्शिया. किंवा आपल्याला I is equal to summation I goes to 1 to n mi ri square is called moment of inertia. So moment of inertia, in the last syllabus we used to define like this. Moment of inertia of a rigid body is defined as sum of, since it is summation, sum of product of mass of each particle, a square of perpendicular distance between the axis of rotation of each particle. Now in the new syllabus, the physical quantity is same, but the terms we are using is different. So moment of inertia of a given body about a given axis of rotation depends upon mass of each particle, mass of each particle, mass of each particle. First, each particle. Second, it depends upon the distribution of mass of body. How the mass of body is distributed. Moment of inertia, in the last syllabus we used to define like this. Moment of inertia of a rigid body about the given axis of rotation is defined as the product of sum of, since it is sum plus sum of product of mass of each particle and a square of the distance between axis of rotation and position of particle. Now in this syllabus, in the new latest syllabus, new terminology is used. How moment of inertia depends upon first mass of each particle of rigid body. Second, it depends upon distribution of mass. Distribution of mass of rigid body. Okay. So by this way, या पद्धतीनं आपण मासला एनालॉगस क्वांटिटी मोमेंट ऑफ इनर्शिया काढली. ठीक आहे. If the body is, say, the distribution of mass of body is finite, म्हणजे दोन पार्टिकल मधला अंतर बराचसा आहे, कंटिन्यू नाही. If it is not continuous, sometimes आपण एक करायचं तो दुसरं भेटते. मोमेंट ऑफ इनर्शिया डिफाइन करायचं होतं तर कायनेटिक एनर्जी मग मोमेंट ऑफ इनर्शिया डिफाइन केली. तुम्ही जर सायन्स मध्ये गेला तर मेडिकल फील्ड मध्ये गेलात, MRI वगैरे आपण काय म्हणतो लाई डिटेक्टर हे सगळे जे आहेत ऍक्च्युअली हे जे मशीन्स आहेत मिलिटरी सेक्शन मध्ये मिलिटरीमध्ये उपयोग करायचे. का तर एखादा विरोध देशाचा माणूस पकडला गेला त्याच्याकडून लाई डिटेक्ट करून सगळं पोस्ट करा. ते आता कशामध्ये आले पोलीसकडे आलेले आहे. असंच मग आपण काय केलं रोटेटिंग बॉडीवरून मोमेंट ऑफ इनर्शिया काढली. इन द केस व्हेन द बॉडी व्हेन द मास ऑफ बॉडी इज फायनाइट और डिस्क्रीट असं असेल तर, आणि इफ सपोज द मास ऑफ बॉडी इज कंटिन्युअस असेल, see try to understand. Moment of inertia I is equal to summation I goes to 1 to n mi ri square. This is in the case when the distribution of mass of body is finite or discrete. The mass of the body is continuous. Under such a case, what we do is we divide the body in a large number of small quantities of equal masses of small elements of equal mass. Instead of individual mass m, it is divided in large number of small elements of mass dm of equal mass. त्या बॉडीचा जेवढा काय मास आहे त्याला इक्वल पार्ट मध्ये डिवाइड करतो आणि एक पार्ट घेतो मास dm, त्याची पोझिशन आहे r फ्रॉम द ऍक्सिस ऑफ रोटेशन. मग आपल्याला ह्या एलिमेंटचं मोमेंट ऑफ इनर्शिया या ऍक्सिस वरती, एलिमेंटचं मोमेंट ऑफ इनर्शिया या ऍक्सिस वरती I is equal to and mi ri square, mass into distance square, mass dm, distance square is r square. हे एका पार्टिकलचं झालं. टोटल रिजिड बॉडी आहे, असे अनेक पार्टिकल आहेत. ह्या सगळ्याची बेरीज करायची. ह्या सगळ्याची बेरीज करायची म्हणजे मोमेंट ऑफ इनर्शिया ऑफ बॉडी I इक्वल टू समेशनच्या ठिकाणी आपण काय करतो इंटिग्रेशन dm r स्क्वेअर. मास डिस्ट्रीब्युशन कंटिन्युअस असेल तर आपल्याला काय रिजिड बॉडीचा मोमेंट ऑफ इनर्शिया या पद्धतीने काढतो. डिस्क्रीट असेल तर असं काढतो. आता तुम्हाला सांगायची गरज नाही. याची युनिट काय होऊ शकतो? युनिट ऑफ मोमेंट ऑफ इनर्शिया I इज इक्वल टू मास इज kg, डिस्टन्स इज मीटर स्क्वेअर, डायमेन्शन तुम्ही काढू शकता. आता प्रश्न कसा आहे? whether moment of inertia is vector quantity, whether it is a scalar quantity. It is neither scalar nor vector. स्केलर ही नाही, वेक्टर ही नाही. कुठली क्वांटिटी आहे? विच क्वांटिटी इट इज? होमवर्क आहे, तुम्ही शोधा, स्वतः अभ्यास करा काहीतरी. मोमेंट ऑफ इनर्शिया हे कोणती क्वांटिटी आहे? स्केलर ही नाही, वेक्टर ही नाही, हे आहे टेन्सर क्वांटिटी आहे. काय? टेन्सर. ओके. So we have defined moment of inertia of a rigid body. Now let us determine moment of inertia of a ring. Moment of inertia of symmetric bodies. Out of that, let us first discuss moment of inertia of a ring. Moment of inertia of a ring. Symmetric bodies. सुरुवातीला आपण काय करू? सिमेट्रिक बॉडीज मध्ये जसं रिंग आहे, डिस्क आहे, स्फियर आहे किंवा रेक्टँगल आहे, युनिफॉर्म रॉड आहे, या सगळ्याचं मोमेंट ऑफ इनर्शिया एक एक करून पाहू. तर रिंग म्हणजे काय? रिंग इज अ सर्कल. इट इज अ बॉडी हॅव्हिंग अ शेप ऑफ सर्कल. An object is said to be ring. एखादा वस्तू त्याला रिंग म्हणतो. केव्हा म्हणतो? if the mass of ring is situated at the circumference of the circle. सर्कलच्या सर्कम्फरन्स वरती आहे. राइट. मग यात पण का करू? बेसिक थिंग करू. लेट अस स्टडी बेसिक. लेट अस सपोज द रिंग इज रोटेटिंग अबाउट एन एक्सिस passing through its center and perpendicular to its plane IC. रिंग असा आहे. रिंग नाही की हो. ओके, समजा ना, बोटातला रिंग काढतो, असा गोल रिंग. इट इज रोटेटिंग अबाउट एन एक्सिस पासिंग थ्रू इट्स सेंटर perpendicular to its plane. As we have studied just now, the moment of inertia depends upon what? Mass of the body and distribution of mass of body. Distribution of mass of body about the axis of rotation. That means moment of inertia changes if the axis of rotation changes. Axis of rotation चेंज झालं की बदलतो. म्हणून आपल्याला याच्यामध्ये बेसिक आपण पाहिलं, rotating about axis passing through the center and perpendicular to its plane. As the mass is distributed at distance r from the center, r is radius of the circle, it is uniformly distributed. Hence, the moment of inertia about this axis is given by IC is equal to m r square. M r square. A ring can rotate perform rotational motion different axes. Let us discuss it afterwards. In this syllabus it is not included. Second axis about a tangent to its plane, tangent in its plane, and tangent perpendicular to its plane, tangent perpendicular to its plane, about its diameter, about its diameter. A ring can rotate in different axes. Main axis is passing through its center, which is mr square. About its diameter, say ID. Tangent in its plane, IT. Tangent perpendicular to its plane, IT dash. IT dash. You can determine the moment of inertia in different axes. In this syllabus, it is not included. It is given in the end of the chapter. All the formulas are given in the chapter. Or in order to determine the moment of a different axis, we have to study two laws or theorems. Not laws, theorems. There, but theorem of perpendicular axis, theorem of parallel axis. तुम्ही theorem of perpendicular axis आणि parallel axis अभ्यास केलं की हे डिटरमाइन करता येते. पण हे डिटरमाइन करण्याची, एक्सप्रेशन करण्याची या सिलेबस मधून वगळून टाकलेलं आहे. फक्त त्याचं फॉर्म्युला दिलेला आहे. तो चॅप्टरच्या एंड पेज मध्ये दिलेला आहे. ते आपण नंतर पाहू. theorem of perpendicular axis and parallel axis उद्या डिस्कस करू. Okay, we'll stop here only. Bye. Let us meet tomorrow.